A palindrome is a sequence of characters that remains unchanged when read backwards. It can be a word, phrase, number, or any combination of those. For example, racecar, madame, and 123, two ones are all palindromes, as when you read them backwards, they spell the same word as the original. Examples of strings that aren't palindromes are hello, Hello, when read backwards is Olleh, ole, and also the string world and 1, 2, 3, 4, 5. The palindrome challenge then is as follows. Given a string, return true if it's a palindrome and false otherwise. The palindrome can be a word, phrase, number, or any combination of those. And to make things simpler, if characters are supplied, assume they're all lower cases. There's many different ways to implement is palindrome. And one approach is to reverse the string and then compare it to the original string. If they're the same, then it's a palindrome, so return true, else return false. Strings in JavaScript don't have any native methods to reverse the string. However, we can reverse the string by first splitting the string into an array of characters, and then using the array reverse method to reverse the characters in the array, and then join them back into a string. And this is done by using native methods called split, which will convert the string to an array of characters, then using the array reverse notation, and then using the array join notation to convert that reverse array of characters back into a string. Let's try and implement this. So we'll declare a reverse string, and we'll use the string split method, and then the reverse method of the array, and then the join method again to combine that array of characters back into a string. And then we just compare the strings. A nice clean solution. Let's go and test this. And the results look all correct. The time complexity of this approach is big O of n, where n is the length of the input string. Splitting, reversing, and joining of the string each take linear time, resulting in a total linear time complexity. Another approach to implementing the is palindrome is to use two pointers or indexes to compare the characters from the beginning and end of the string towards the middle. If at any point the characters do not match, the string is not a palindrome. For example, for the string hello, we will compare H against O, and they do not match, so it's not a palindrome. For madame, we compare the ends of the string, so the characters of the first index and the characters of the last, they match. Then we move towards the middle, A and A match. Then we get to the middle, and they match also. Actually, we don't need to compare the characters of the middle, because we know that will be the same. So we only need to compare up to when the left index is less than the right index. Let's go and try and implement this. We'll declare two variables called left and right, where left is the beginning of the string and right is the end of the string. Don't forget that arrays use base 0 for the indexes, so the first index is 0 and the last index is string of length -1. While the left is less than the right, if the two characters are not the same, then we return false. They aren't a palindrome. We increment the left by 1 and decrement the right by 1. Don't forget, we only need to compare up to the middle and not the middle itself, as the middle will be guaranteed to be the same character. Let's give this a test. And everything looks correct. The time complexity of this solution is big O of n, where n is the length of the input string. The two pointers transverse the string only once, giving us a total linear time complexity. A similar approach to solving the is palindrome is to use a for loop to compare the characters from the beginning and end, but only do it up to midpoint. For this, we only need to keep track of the beginning of the string, and we can calculate the end of the string. Similar to our previous example, if we had the string madame, we would compare the first character and the last character, and then increment the first character to compare A and decrement the last character to compare A as well. We don't need to compare the middle character because that's going to be the same. We also don't need to keep two variables to store the individual indexes. If the variable for the left index is I, we can use the formula of string length minus 1 minus I to determine the right index. For example, if the left index is 0, the right index will be 5 minus 1 minus 0, which is 4. If the left index is 1, the right index will be 3. And the left index is 2, the right index will be 2. Although for this case, we don't need to compare that, as we know that the character will be exactly the same. Okay, let's remove our previous code and give this a try. We can first keep track of the length using a length variable, and also declare a mid variable to determine where the midpoint is. The math.floor method will round down and return the largest integer that's less than or equal to the given number. For example, 6 divided by 2 will return 3. 5 divided by 2, which is 2.5, will return 2. We can use the for loop, and the start index will be I, and we just need to go up to the midpoint, and we increment it by 1 each time. If the string at the start doesn't equal to the string at the end, then we return false as it's not a palindrome. And we can use our formula of length minus 1 minus I to determine the end index based on the start index. And we return true here if everything matches. Let's give this a test. And everything looks correct. The time complexity of this also remains as big over n, where n is the length of the input string. We can also use a recursive approach to check whether two strings are palindromes. We can compare the first and last character of the string, and if they're not the same, then we return false as it's not a palindrome. If they're the same, then we can take the inner string and check it recursively. And we keep doing that until the length of the string is less than or equal to 1, in which case it's a palindrome and we return true. Using our previous example of Madame, we will compare the first and last characters and they're the same. Then we get the middle string of ADA and check that recursively. We check A and D and they're the same. We get the middle string, which is D. Now D's string length is less than or equal to 1, so we return true. That means the whole string is a palindrome. For the example of hello, we check H and O, and they're not the same, so return false. Let's implement this. We'll start for when the string length is less than or equal to 1 and return true. Then we check the first and last character, and if they're not the same, we return false. The last part we need to implement is to get the substring and then recurse through that. We can use the string substring method to get the inner part of the string from position 1 to length minus 1. Let's give this a test. And everything looks perfect. The time complexity of the recursive approach is big O over n, where n is the length of the input string. In the worst case, each character of the string is compared once, resulting in linear time complexity. As always, thank you again for watching this video. If you have any feedback or comments, please don't forget to leave them in the comment section below, and I'll see everyone later.